Section 7.3, multiplying and dividing rational expressions. Going to start with one vocabulary term, rational expression, and this should make sense, a fraction whose numerator and denominator are non-zero polynomials. So in section 7.2, we learned about rational functions where we had f of x was equal to p of x over q of x. Well, basically now we're eliminating f of x. Okay, we're just saying p of x over q of x. We're talking expressions here. We're not talking functions. We're not talking equations. We're just talking expressions here, okay? The goal today, or the goal of this video, is to write these rational expressions in simplified form. And what simplified form means, it means that the numerator and denominator have no other common factors other than 1 or negative 1. Okay, and here are your steps. So the first step is we're going to factor the numerator and denominator separately. Okay, after we do that, we're going to divide out any common factors. So basically, we're simplifying a fraction, and then we're going to write our simplified expression, and we're going to make sure we list any excluded values. And I'm going to show you what all that looks like. One key note here with simplifying expressions: like terms are not common factors. So if I, for example, let me just give you an example here. If I had x plus 6 over x plus 2. These x's right here, they do not cancel each other out. This is not equal to 6 over 2. Okay, these x's do not cancel out. What would have to cancel out is if they were both x plus 6. Then they would cancel out. Okay, but like terms, like these x's right here, these x's do not cancel each other out. Okay, so if it's x plus 6 or x plus 2, that's as simplified as you can get. The x's, the like terms, are not common factors. They cannot be factored out. Okay, so let's dive right into one here. So we're going to have 2 over x plus 1 divided by x plus 1 over x plus 3. So the first step says to factor the numerator and denominator. And in this first one, it's already done for you. This is a monomial. This is degree 1. This is degree 1. This is degree 1. Everything is as factored as it can be. Both the numerator and denominator are factored completely. If you remember that vocabulary term from, I believe it was chapter 4. Okay, chapter 4, I believe, factored completely. So we've already taken care of factoring the numerator and denominator. Now we can go ahead and divide out any common factors. So there is one common factor here. It would be x plus 1. The numerator and denominator both have x plus 1. So the x plus 1s cancel out. That's the only thing that we can simplify. So then our final answer here is going to be 2 over x plus 3. And you don't really need parentheses around the x plus 3. I'll put it in there just so I have it. But you don't really need it. If it's just the single binomial, you don't really need parentheses around it. Now, the excluded values. So if we think about putting this in our calculator, because right now you would think that these two expressions are equivalent, but they are in fact not equivalent. So what I did in the graphing calculator, I typed out 2 times x plus 1 divided by x plus 1 times x plus 3. So basically I typed the original one in the y1 screen, and then I typed the answer 2 over x plus 3 in the y2 line. Now, when you're typing it in the calculator, you do need parentheses around your numerators and denominators if it's more than one term, like the x plus 3. If it's just 2, you don't really need it. You are going to be using parentheses. Parentheses are your friend here with this section. So get used to using parentheses and use more parentheses than you probably think you need. Okay, so when you put these two in the calculator and then you look at the table, you know, every one of those values lines up except this one. Okay, it's the negative 1. So negative 1 would have made the original expression undefined. It wouldn't have worked. Okay, but negative 1 does work here. So in order to keep these equivalent, in order to be able to use this equal sign, we also have to list the excluded value where we have to say x cannot be equal to negative 1. Every other term here, okay, every other term in these two columns are the same except for that x value of negative 1. So wherever there's an inconsistency in your y values, that's the x value that you need to list or need to exclude from your answer. So your answer here is 2 over x plus 3, also including that x is not equal to negative 1. Let's try another one here. X plus 4 over x squared minus 16. Now, the numerator is already simplified. It's a degree 1 polynomial. but the denominator is not. And what I hope you can see is that x squared minus 16 is a difference of squares. Okay, so we can write the difference of squares pattern, x plus 4 times x minus 4, and that all of that is under x plus 4. Now, that works out really well because we do have a common factor. We have x plus 4 on the top, we have x plus 4 on the bottom, so those will cancel each other out. So what's left? Well, we can say that our answer, if we got nothing left on the top, we can say it's 1 over, well, what's left on the bottom? It's x minus 4. Once again, you need to go and check in your calculator what values work, what values don't, and I've already done that. So we've got x plus 4 over x squared minus 16, and then I've got 1 over x minus 4. So I've got our original in the y1, I've got our new answer in the y2, and we take a look at our table. And what you can see, everything matches up except that x value of negative 4. Okay, in the original it gave us an error because it's undefined. You can't use negative 4 in the original one, but you can use it in the new one. So to keep these two expressions equivalent, the original one and the one in red, our final answer, we need to exclude that one value where it's inconsistent. So where our answer is going to be 1 over x minus 4, and x cannot be equal to negative 4. That's the excluded value we need to list. All right, let's try a couple more. Number 3, 4 over x times x plus 2. Well, 4 is a monomial. It's one number. You cannot simplify that. The denominator, x over x plus 2, that is also factored completely. And now what you can see here is there are no common factors here. Okay? We have nothing to cancel out from the top to the bottom. So what we can say here is we can say this is simplified. This is as far as we can go. We cannot take any common factors out. There won't be anything to exclude other than writing simplified. This is the final answer. There's no other work to do. There's nothing to cancel out there. So our answer, simplified, it's done. Let's move on. Number 4, x squared minus 2x minus 3, x over x squared minus x minus 6. Now with this one, both of them need to be factored. So both of them have 1s in front, which is really good, which means we can go right to parentheses. I'm going to have x's all over the place. X, 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 x. Okay, so for the numerator, we're looking for two numbers that multiply together to get negative 3 and add together to get negative 2. Those two numbers would be negative 3 and positive 1. And then on the bottom, I'm looking for two numbers that multiply together to get negative 6 and add together to get negative 1. And those two numbers would be negative 3 and positive 2. Now what I hope you can see now, when we factor the numerator and the denominator, what we have is we have a common factor. We can factor out the x minus 3s. We can basically eliminate those. So then our final answer is going to be, and I'm going to write this down here below, since we don't have the x minus 3s, we're just going to have x plus 1 over x plus 2. Now, once again, since we've canceled things out, we should probably go back and take a peek at the calculator. So when I plug in the two original expressions, the original, okay, x squared minus 2x minus 3 over x squared minus x minus 6, and then our answer, x plus 1 over x plus 2. When you go in, take a look at the calculator. Again, negative 2, they both have errors, so we're good there, but we do have one inconsistency. We have that inconsistency at 3. Okay, so when we have that inconsistency, that's the one we need to list. We need to say that x cannot be equal to 3. And now this is equivalent to our original expression. Okay, I've just got one more little note here. So in general, excluded values must be listed when they would make the original expression undefined, but not the simplified expression. Okay, so then this last note says if a value would make both expressions undefined, it's not necessary to list it. So you can see that here in this last example. Must be listed to make the original expression undefined, but not the simplified. So we've got that right here with an x value of negative 3. It makes the original undefined, but not the simplified. So we need to list 3. Negative 2 does not need to be listed because it makes both expressions undefined. So we're assuming that we can't use negative 2 in either answer. Okay, so that's why we need to list 3 but not negative 2. If it makes one undefined but not the other, you need to list it. But if it makes both undefined, you do not need to list it. All right, let's move on to multiplying rational expressions. Rational expressions are simply fractions. So just a reminder, when we're multiplying fractions, it's top times top, bottom times bottom, and then we're going to simplify. It's really not that difficult. Okay, so let's jump right in. So 3x to the 5th y to the 2nd over 8xy times 6xy squared over 9x cubed y. So let's multiply top times top, bottom times bottom. On the top, we got We get 3 times 6, which is 18. We have x to the 5th times x, which is x to the 6th. And y squared times y squared is y to the 4th. Do the same thing with the denominator. 8 times 9 is 72. X times x cubed is x to the 4th. And y times y is y squared. Okay? So now, let's keep going. Let's simplify things here. Let me change colors. We'll go to green. So 18 over 72, basically I'm going to split this into 3 fractions. Okay? 18 over 72 simplifies down into 1 over 4. So I'm going to have 1 over 4. X to the 6th over x to the 4th is x squared using our quotient of powers property. If you have the same base and you're dividing, you subtract your exponents, top minus bottom. And the same thing with the y's. Y to the 4th over y squared gives me y squared. Now, when we, excuse me, when we write our final answer, we need to be aware of excluded values as well, okay? So in this final expression, it would appear that you could use any value for x and y and get a defined answer. But if you look back in the original expression, we have x's and y's in the denominator, which means we can't have the denominator be 0. Okay, the value of x that can't be used would be 0, because if you have 0 on the bottom, then it doesn't work. Same thing for y. Okay, so what we need to list here is when we write our final answer, I'm going to write this in purple here. We're going to say we're going to have x squared y squared over 4, but x can't be 0 and y can't be 0. Okay, you would think that you could use 0 in our final answer, but you have to go back and recognize the original expression or the original problem here. You cannot have 0 in the denominator, and an x value of 0 would make that happen. A y value of 0 would make that happen. Okay, so we cannot have those two when we write our final answer. Let's try another one here. 3x minus 3x squared times x squared plus x minus 20. And then that's all over x squared plus 4x minus 5 times 3x. Now, what I'm going to suggest, let's factor everything here. Let's factor everything. So 3x and 3x squared are both divisible by 3x. So I'm going to go 3x. And if I divide them both by 3x, that gives me 1 minus x. And then let's factor the bottom of that first fraction. We're going to have, let's see, x squared plus 4x minus 5. We need two numbers that multiply together to get negative 5 and add together to get 4. Those would be positive 5 and negative 1. The denominator, let's see, I'm going to have 3x on the bottom. That's simplified as far as we can go. And the numerator, we need two numbers that multiply together to get negative 20 and add together to get positive 1. That would be positive 5 and negative 4. Okay? Also, with this 1 minus x, I'm actually going to rewrite this as negative 1 times x minus 1. Basically, I'm flipping the signs of these two terms by dividing by negative 1 and then just reordering them so the positive x comes first. Okay, so when we write this out, it's going to be, let's see, we're going to have negative 1 times 3x times x minus 1 times x plus 5 times x minus 4. And that's kind of scrunched on the side there. All over, let's see, we've got 3x, and we have x minus 1, and we have x plus 5. Okay? So we got a mess, but it's an organized mess. Okay, so the 3x's, they cancel. Let me erase that. Cross out the 3x's. They both have x minus 1, so we can factor that out. They both have x plus 5, so we can factor that out as well. So let's just write what's left, because we've factored out all of our common factors. So we're going to have negative 1 times, and we'll put equals, negative 1 times, let's see, I don't have 3x, I don't have x minus 1, I don't have x plus 5. All I've got left is x minus 4 on the numerator. Now in the denominator, let's see, gone, gone, gone. I got nothing left, so that would be a denominator of 1. So really, you could leave it as this, or if you wanted to, you could say negative x plus 4. But we have to think about our excluded values. Think about our denominators here. What value of x would make 3x? 0, because we don't want the bottom to be 0. That would be 0. So our answer is going to be x, negative x plus 4. X cannot be 0. X cannot be 1, because 1 would make this middle factor 0. So x cannot be equal to 1, and x cannot be equal to negative 5. For the same reason, negative 5 would make this one 0. So our final answer is actually all of this. Okay, we got 3 excluded values, 3 numbers that we can't use, but this is the remaining expression. Negative x plus 4, x can't be 0, 1, or negative 5. Let's try a third one here. X squared over x cubed minus 27 times x squared plus 3x plus 9. All right, so let's see, the denominator of our fraction, this right here, x cubed minus 27. If you remember section 4.4 where we actually factored polynomials, the denominator should remind you of a difference of cubes, and the difference of cubes actually has a nice little pattern. So our numerator is still going to be x plus 2. Our denominator is going to be a little longer, so it's going to be x minus 3 over x squared plus 3x plus 9. That's the difference of, that's the difference of cubes. I'll write that off to the side. It's a difference of cubes, and it's in section 4.4, right here, the denominator, okay? And then, let's see, that's factored for the left fraction. Now for the right one, really we can just leave it as x squared plus 3x plus 9 all over 1. Since there's no fraction, we can just make it over 1. And what stands out to me, we could rewrite this where it's all one term, one fraction. So we'll have x plus 2 times x squared plus 3x plus 9 all over x minus 3 times x squared plus 3x plus 9. And what I hope you notice is that both of them have that x squared plus 3x plus 9 term. So this cancels with this. So what are we left with? Well, we're left with x plus 2 over x minus 3. Now the question becomes, do we have any excluded values? Now, if you try to solve this, x squared plus 3x plus 9, what you're going to find is that there are no real solutions. If you graph, let me change colors here. Let me go to orange. If you tried to graph this and look where it crosses the x-axis, what you're going to find is something that looks kind of like this. If you were to graph it, you would see something up there. What that means is that there's no x-intercept. There's no real solution to make this to where it crosses the x-axis, which means this x squared plus 3x plus 9 doesn't have any real zeros, meaning there's no way you could make this equal to 0. So even though we canceled it out, we don't need to worry about listing excluded values because this doesn't cross the x-axis. There's no x value, no real x value that would make this whole thing 0. Okay, so we're just left with x plus 2 over x minus 3, and that is going to be our final answer. We don't have any excluded values because there's no value of x that makes this 0, the x squared plus 3x plus 9. All right, let's move on to dividing rational expressions. So I know you've heard this before, dividing fractions, that's our cry, flip one over and multiply. We're going to do the same idea, okay? When we find the quotients, when we're dividing fractions, we multiply by the reciprocal of the second expression. So the first example here, 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. So we're going to multiply by the reciprocal of the second expression. So I'm going to take this expression, the second fraction, and I'm going to reverse it. I'm going to make it the reciprocal. So this is going to be 7x over 2x minus 10 times the reciprocal. So we're going to have x squared minus 11x plus 30 over x squared minus 6x. Whoops, let me make that an x. 6x. Okay, so now we're basically back to the previous examples where we're multiplying. Let's factor the second fraction, the top side and the bottom side. The bottom of the first fraction we can also simplify just a little bit. So both of these are divisible by 2, so we'll divide both of those by 2. So do this in purple. So the top fraction, first fraction, top side is not going to change, 7x. Bottom fraction, or bottom side of the first fraction, we can take a 2 out, so this becomes x minus 5. And then we'll have times, let's see, x squared minus 11x plus 30. The number in front of x squared is 1, so we can go right to parentheses. We'll have x, we'll have x. Two numbers that multiply together to get 30, add together to get negative 11. Those would be negative 6 and negative 5. And then the bottom side, x squared minus 6x. Both are divisible by, it looks like just x. So then when we take x out, we get x minus 6 in return. Okay, so just in the sake of saving space, I'm not going to write out the next line where I just write it all as one big fraction. We can kind of think of it, though, that way. That's what's going to be happening. So let's just think about, simplifying. Both fractions have an x minus 6, so those will cancel out. Both fractions have an x minus 5, so those will cancel out. And both fractions also have an x value, just x, because this is 7 times x, okay? So the x and the x, not the 7, just the x, cancel away. So what are we left with? Well, on the top, looks like we have a 7 and nothing else. So it's going to be 7. On the bottom, looks like x minus 5 is gone, x is gone, x minus 6. The only thing left is 2, 7 halves. Now, even though we just have a number remaining, we do still have to think about our excluded values. What values of x make the original expression equal to 0, or make it undefined that we canceled out? Okay, looks like this would be 0, this one would be 5, and this one would be 6. So our answer is going to be 7 halves. Even though there's no x, we still need to list that x cannot be 0, x cannot be 5, and x cannot be 6. Okay, so this is our final answer, 7 halves, where x is not 0, x is not 5, and x is not 6. Even though there's no x in our final expression, we still need to list out the ones that are not able to be used. Number 2 here, 4x over 5x minus 20 divided by x squared minus 2x over x squared minus 6x plus 8. Same idea, we're going to multiply by the reciprocal instead of dividing, so we're going to make this, let me rewrite that, so it's going to be 4x on top, 5x minus 20 on the bottom, times, let's see, we're going to have the reciprocal, so x squared minus 6x plus 8 all over x squared minus 2x. Okay, so now we're going to factor again. 4x can't be factored, but 5x minus 20 does have a factor that we can simplify. So we're going to have 4x on the top. 5x and 20 are both divisible by 5, so we'll make that x minus 4 times, let's see, x squared minus 6x plus 8 can be factored. Let's see, so we'll have x, two numbers that multiply together to get 8, add together to get negative 6. Those two numbers are negative 4 and negative 2. And on the bottom side, x squared minus 2x, both are divisible just by x, so then we'll have x minus 2 remaining. Those are good numbers because you can see that we have x minus 2s, we have x minus 4s, we also have x's as well. So let's go ahead and take away things that are in common, the x minus 4s, the x's, the x minus 2s. So what are we left with? Well, it looks like we're just left with 4/5, but again, we need to think about our excluded values. What values of x make this original expression undefined? What makes it not possible to happen? Well, it looks like 0, 2, and 4. So we're going to say that the original expression, this whole big ugly fraction divided by another fraction, is equal to just 4/5, as long as x is not equal to 0 or 2 or, x is not equal to 4. Okay, so whatever x value you put in for this expression, as long as it's not 0, 2, or 4, it's going to work, and the answer every time is going to be 4/5. That's really what that is saying. All right, number 3, 6x squared plus x minus 15 divided by 4x squared, or all over 4x squared divided by 3x squared plus 5x. Now, since we don't have a fraction in the first or in the second part of the expression, we can make it a fraction, just put it over 1. And then when we multiply, it's going to be 6x squared plus x minus 15 over 4x squared times 1 over 3x squared plus 5x. Now, this 6x squared plus x minus 15, this has a number in front of x squared that isn't 1, which means we need to do the long method, the factor by grouping. So I'm going to do that, I'll do that in red, and I'm going to do that off to the side here. So remember the steps, we need to take a times c, so 6 times 15, negative 15, that would give us negative 90. I need to find two numbers that multiply together to get negative 90, so something times something else equals negative 90, and then those same two numbers have to add together to get 1. Now, those two numbers that we're going to use are going to be 10 and negative 9, okay? 10 times negative 9 is negative 90, 10 plus negative 9 is equal to 1. So now step 3 then is to rewrite this middle term using these two numbers that we just came up with. So we're going to have 6x squared, I'm going to go with 9x first, minus 9x plus 10x minus 15, and then we're going to factor from there. Factor our pairs, first two, last two. 6x squared and 9x are both divisible by 3, also x, so that leaves me with 2x minus 3. 10 and 15 both divisible by 5, so we're going to have Let's see, 2x minus 3 again. Remember, they're supposed to match, so then our product would be 3x plus 5 times 2x minus 3. Okay, so now when I rewrite this, I'll have my top first, or my numerator on the first fraction is going to be 3x plus 5 times 2x minus 3. This 3x squared plus 5x can be simplified down to, well, they're both divisible by x, so we can make that 3x plus 5. That's going to be a great help down the road. 4x squared times, so 4x squared times this becomes, we'll just make it, let's see, go back to red, we'll go 4x squared times x times 3x plus 5. Now, what's left, or what can we cancel out? Well, the only factor we can cancel out are the 3x plus 5s, okay? So our final answer then, when we simplify our expression, we're going to have 2x minus 3 on the top. On the bottom then is going to be, let's see, we got 4 times x squared times x, which leaves me with 4x cubed. Now, once again, we need to think about excluded values. What value of x made this part that we canceled out equal to 0? So if you set this equal to 0, what you're going to find is that x cannot be equal to negative 5/3. So pick any x value you want, as long as it's not 5/3. Plug it into your original expression. You can plug it in here. Either way, this would be how you would find your y value. And once again, as long as x is not equal to negative 5/3. This right here is your final answer. All right, I'm running a little short on time, so here's what I'm going to do. I'm going to give you the story problem. The total amount I, in millions, of personal income earned by a town and its annual population P, also in millions, can be modeled by those two equations. I equals 861x plus 72957 over 0.0059x plus 1, and P is equal to 0.0388x plus 3.054, where x represents the year with x equals 1 corresponding to 2011. What I want you to do, I want you to set up or write up the story problem, and then I'm going to go through this in class because I'm running short on time and I don't think I can get it done here in the next 3 minutes. So what I want you to do, pause the video, get this story problem written down, set up. First question, find the model M for the annual per capita income. That's where we'll start in class.